Hello, everybody. So here are some applications for parabolas. The key thing with these applications with parabolas, there's really only a couple of things. You're either finding the vertex or the zeros. So in the context of the problem, you just have to be aware, do you need to find the vertex, so the maximum or the minimum? Or are you finding the zeros? Remember, the zeros are the x values that make the parabola equal 0. Our first example here talks about a shot put thrower throwing at an angle of 35 degrees. Luckily, we don't have to come up with the function. We just have to analyze it. The function is this. F of x is, of course, the y value, and x is the independent variable. The independent variable x is not time, but it is the horizontal distance from the athlete. So she begins throwing it here, and she throws it. I think we're working with with the blue parabola. So she throws it way over here. So farther than 70 feet, but not quite 80 feet. And then the height of the shot put is determined by the y in feet again. And letter A, what is the maximum height? Well, that is, of course, the vertex of this parabola. And notice the parabola is facing down. We knew that because A is negative. So if A is negative, it's facing down. That means it has a maximum, and it's about finding the vertex. So again, the y value is the height based on the horizontal distance, and these two x values are going to represent the horizontal distance from the athlete. So finding the vertex is negative b over 2a. The vertex for any parabola, the x value is negative b over 2a, and what's the y value? The y value is just the result of plugging in negative b over 2a. And since x is negative, we know we've got a maximum. So here's my a, here's my b. I plug it in very carefully, get my calculator out. I discover 35 is negative b over 2a. So that means that the height of the shot put occurs when the shot put is 35 feet away from the athlete. Remember, x is 35. The actual height, the maximum height, is the y value. So to find that, we plug in 35 into the function, and we get 18.35. So this is the answer to letter A. We know a lot about the height of this shot put. It reached its maximum height 35 feet away from the athlete, and that maximum height was 18.35 feet. And just a quick check at the graph to make sure that the numbers match the graph. Is, we can't really be precise, but we can make there's evidence to suggest we're right. Here's the vertex somewhere around here. This looks like the x value is 35, and the y value, the height, is 18.35, so I'm feeling pretty good. Letter B is, what's the shot's maximum horizontal distance? In other words, how far did she throw this shot? Well, look at the graph, it's somewhere in the upper 70s. But realize it is the zero of this parabola. So I'm going to set this parabola equal to 0 and solve. Setting it to 0, hopefully you have a tendency to factor, since factoring is so fast, but this one would be, it's not factorable, but even to try to factor it would be not fun. So we have a couple things we can rely on. Completing the square. I don't want to do that either. So quadratic formula. Probably quadratic formula is the most popular way, which is the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. So I first determined the discriminant. Remember, guys, the discriminant is 0.734. It's not the square root of 0.734. It's just 0.734. And since the discriminant is positive, I know I got 2 real answers. And furthermore, since it's not a perfect square, it's not factorable. So I would have been wasting my time if I even tried to factor that. And I go to my calculator, I take the square root of 0.734, and I get this nasty number. And now I separate it into plus or minus, because of course, parabolas have 2 solutions. When I first separate it into the plus version, negative 0.7 plus 0.85 divided by negative 0.02, I get an answer of negative 0.78. Now, mathematically, that's a correct answer, but we are using math to solve a real problem. And since x represents the horizontal distance from the athlete, this answer needs to be rejected because you cannot have a distance of negative 7.8. Looking at the graph, you can imagine if you continue the parabola to the left, it would hit the x-axis at negative 7.8. But as a credit to this textbook, it doesn't even show you these values over here because it would make no sense. This is a real shot put person, and she begins at 0, and she throws it to whatever that value is. She can't throw it negative 0.78 anywhere. So the other version is negative 0.7 minus this. And when I evaluate that, I get 77.8. So when x is 77.8, y is 0, so it's on the ground. That is how far she threw it, 77.8 feet. And lastly, from what height was the shot released? In other words, what height did this shot put begin? It didn't begin on the ground and she hoisted it up and threw it. It began on her shoulder and she pushed it out. Well, how high exactly? Well, at the beginning of her throw, the distance from her is 0. Remember, x represents the distance from the athlete. So this is finding when x is 0, what's the y value? Thank you, bless me. So f of 0, really don't need to show work here, but you plug in 0, all that's left standing is the constant, which is 6.1. So that is where she released the shot, 6.1 feet in the air, and she hoisted it all the way up to 18.35 feet in the air, but it eventually landed 77.8 feet away. 2 more to go. This is such a classic problem. You've got 600 feet of fence and you want to build a rectangular plot. Thank goodness it's a rectangle. But not so simple because there's a river that's going to border one side of your rectangle. So you're only really responsible for constructing 3 walls of this rectangular pen since the river is acting as one wall. Well, you can draw out a rectangle using the river as a boundary. And remember, it's a rectangle that makes all the difference in the world. Since a rectangle has 2 opposite sides that are the same, I don't know what this distance is, so I'll just call it x and let it vary for all possible x values. And I use a certain amount of fence here and a certain amount of fence here. Well, how much is left over for this third and final piece? Remember, I only had 600 feet to begin with. So if I have 600 to begin with, I construct this wall, so that's 600 minus x, and then I construct this, so that's 600 minus 2x. That's what I have left to construct this third wall, 600 minus 2x. And incidentally, if you add up all 3 walls, x plus 600 minus 2x, guess what you get? You get 600 because all 3 of them have to add up to 600. That's how much feet you have to do this. And then we need to find the length and the width of the plot that will maximize the area. The area of a rectangle is always and will always be length times width. And that's good news because I know the length is 600 minus 2x and I know the width is x. So I can write an area formula. The area based on x, so based on the width, is the width times the length, x times 600 minus 2x. I distribute and I get negative 2x squared plus 600x. This parabola generates all possible areas of this rectangular pen. It generates all possible areas. And notice the a value is negative, so that means it's facing upside down, which means it has a maximum. So there is an area that is the greatest area, greater than any other possible area under these conditions. So to find that, we of course find the vertex. Negative b over 2a results in 150. So when x is 150, that will tell us the length, this x value, that will give us the maximum area. And the maximum area, excuse me. First of all, you could just type in 150 here. Since we know x is 150, I could type in 150 here. 2 times 150 is 300. 600 minus 300 is 300. So I could just realize that this is 150 and this is 300, and then multiply both of those things and get my final area, 45,000. But I already have a function that tells me the area, so I might as well use it. Plug in 150 for x, and I get 45,000. This is the greatest area. So everything that's in red is the final answer. Everything above it supports this final answer. The width should be 150, which would make the length 300, and an area of 45,000 square feet. That is the greatest area possible under the conditions set by the problem. Last example. If you're a vegetarian, I'm sorry, this is disgusting to you. Fortunately, I'm not a vegetarian. This one just makes me hungry. So there's some sort of hunky beef. That's hilarious. Store sells roast beef sandwiches, thank God. And what do we know about it? There's a fixed, so that means there's always going to be a weekly cost of $525. Whether or not, if they have no electricity for a week, too bad. It still costs $525. If they sell a million sandwiches or if they sell 0 sandwiches, they're always going to have that cost of $525. But then also 55 cents per sandwich. So letter A is asking, how do you create a function that encapsulates all the costs in a single week for this store? All the costs. Well, there's only 2 things that contribute to the cost: the fixed cost plus the cost per sandwich. And if you're thinking of the word per, you're very likely thinking of the operation multiplication. This will just be a line, not a parabola. It's 55 cents per sandwich, so x would represent the amount of sandwiches, plus 525. So notice 525 does not depend on how many sandwiches you sell. Whether you sell 0 or a million, you're still tacking on that 525. That's letter A. Letter B, I'm told that the revenue is this. So this is how much money the hunky beef brings in per week, based on how many sandwiches they sell, based on X. So obviously, if they sell 0 sandwiches, they are bringing in $0. And the profit, we have to come up with a profit function. So how do I determine the profit? Well, I hope we know that the profit is all the money you bring in, revenue, minus all the costs that you have to do. So the profit is simply revenue minus costs. And profit as a function of x would be r as a function of x minus c as a function of x. So everything depends on how many sandwiches they sell. Now, this last one you have to be careful, because I'm sure you could substitute r of x. This was given to you. But when you minus c of x, c is composed of 2 parts, 2 terms. So you would need parentheses to ensure that you are subtracting the entire function c, not just 0.55x, but the whole thing. So parentheses. Simplify, and you get this as your final function. This function represents the profit of this store based on how many sandwiches they sell. And it's a parabola with a as a negative, so that means it's facing down, which means it has a maximum, which we're probably going to have to find. Letter C, use the function, the profit function, to find out how many sandwiches they should sell to maximize the profit. And then tell me, what is the maximum profit? Well, that's, of course, the vertex again. Negative b over 2a. Using negative b over 2a, we discover we get 1225. What does that mean? If this store sells 1,225 sandwiches, it will maximize the profit. The profit will be maximized. What is that profit? Plug in 1225 into the profit function. The profit function tells you the profit if you know how many sandwiches there are. So we know that there are 12 1,225 sandwiches. That will tell me the maximum profit, $975.62. So this is the final answer, this sentence. And all the work above it supports it. That's the last example, but I want to just meditate on this graph right here. This is the profit function graphed. And notice the vertex is 1225. So that's X. That's how many sandwiches we sell in a week. And then Y is the profit in dollars, $975.62. But what do all these sections represent? It's like, what does this section represent right here? Notice all the Y values in this section are under the maximum Y value. So we're not making that much profit here. This represents if we sell less than 1,225 sandwiches, then we're simply not making that much profit. So we don't make as much profit. Well, how come, how do you understand this over here? If I make more than 1,225 sandwiches, how does it make sense that I actually make less money? I mean, if you're the owner of Hunky Beef and your employees say, guess what, boss? We sold 2,000 sandwiches this week. That's a record. That would be bad news. Why? According to this graph, selling 2,000 sandwiches only gives you about $400. Where if you only sell 1,225 sandwiches, you get $975. How does it make sense that selling more sandwiches results in less money? Because there is that cost. Remember, it costs money to make a sandwich. It costs 55 cents per sandwich. So as soon as your employees make more than 1,225 sandwiches, the cost of making sandwiches overpowers all the revenue that you're bringing in, making you earn less profit. So the sweet spot is that vertex. What about these two values? These are the zeros. How do you understand this in the context of that problem? The two zeros are 237 and 2,213. How does that make sense in the Hunky Beef scenario? Well, the Y value is both zero for these. So if your employees make exactly 237 sandwiches, or if they make exactly 2,213 sandwiches, then the cost of making the sandwich and the revenue they pull in from those sandwiches are equal to each other. The cost and the revenue are equal. And if your costs are exactly equal to how much money you're bringing in, then you're not making any profit. Your profit is zero. Well, what about these Y values that are negative? If a Y value is negative, we're talking about money, then this means we're losing money, right? So if you make 2,400 sandwiches, you should fire that employee because they're not listening. If your employee makes and sells 2,400 sandwiches, you are going to be out of business because that is so costly. It costs so much money to make that many sandwiches that it overpowers all the revenue you brought in from those sandwiches, making you lose money. So these X values over here, you're just making so many sandwiches, it's just way too costly and it's ruining all of your profits. And these X values, producing the negative Y values, you're making too few sandwiches. So you're not bringing in enough revenue and your costs are still burying you. So again, that vertex is just perfect. If you could just make exactly 1,225 sandwiches per week, you will have an excellent business, maximize profit every single week.